Good morning, everyone. Happy Friday. Thanks for joining for another session of Azure Power Lunch. Today, now I'm going to hand over to Malik. Malik, go ahead, talk about your session and about yourself. Malik, are you on mute?
Yes, can you hear me okay now?
Yeah, we can hear you.
Okay, sorry about that. So I had this. All right, so quick introduction. My name is Maulik Soni. I'm a cloud solutions architect at Microsoft. And today's topic for presentation is Azure Premium Functions. And we will be focusing on the networking capabilities. So just a quick recap, functions are built on top of Azure App Services infrastructure. So they share a lot of different characteristics underneath with app services. And functions has different plan types you can choose from. So we have consumption functions, purely event-based scaling. You don't have to worry about the underlying infrastructure. The another plan we have is the app service plan. So in that you actually have to create an app service plan and which can be shared between functions and web application. And for the best network isolation and network integration, the app service environment is a dedicated plan of app service where a virtual network is app service is injected into your virtual network, providing you the full isolation. Today we will be talking about the Elastic Premium plan for app service. So the premium functions utilizes the Elastic Premium plan, and we'll be sharing uh, the different capabilities right next. So another quick recap is that the premium functions are built on top of the multi-tenant app service plans, right? So on the extreme end, you have the app service environment, which are like completely isolated, and you can have just one customer running on it, while the premium functions are built on the same app service plan that's been in work. Okay, so a few highlights here comparing the premium plan. First of all, the scale. So Azure Premium functions have a bigger and configurable instances, for example, from 4 cores and 12 gig of memory. Premium function also has a minimum plan size and pre-warmed instances. So you can always have one instance running. Whenever a function request comes in, a pre-warmed instance returns the request. So it's much more faster than a cold start. Also, the big functionality that we will be taking a look today is the VNet connectivity. So virtual network integration and an integration with private link service is now available in premium functions. Also, premium function has a long run duration than the normal consumption function and app service based function. Okay. So the reason for functions to run inside a virtual network is probably enhancing the security at the best. But if we further break down that, so if we have a requirement to restrict the inbound traffic as well as the outbound traffic, um, if you have a network compliances that can monitor and control the traffic, and also you want to connect to an existing networks in Azure through the express route back to on-premises. So these are the key characteristics that why a virtual network integration with private endpoint is a solution for you if you want to achieve any of this in your environment. Okay. So the way the flow works is in order for a network isolation, think of this different steps. So inbound and outbound, right? So inbound, Azure Premium Function supports the triggers within the virtual network. You have a service endpoints to further restrict the inbound traffic, and private link is the ultimate solution to expose a function over private link. So your entire traffic is within the Azure's backbone. And in the middle, you have your code running in Azure Functions. Now, in order for you to make an outbound connection, the security features available are the UDR that you can configure, also the virtual network integration, which allows you to call your function over a configured virtual networks and limits the exposure to the public outside domain, as well as the network security groups, which you can configure and apply in order to what traffic flows you want to allow and what you want to restrict. Okay, so with this, I have two demo examples of using Azure Premium Functions virtual network isolation features, right? So this example is an HTTP client making a call to function app over private link, right? So as you know that whenever you create a function app in consumption or app service plan, your function app is public. When you configure a private link on top of a function in premium functions, you're restricting your inbound traffic. So basically, any client who can go over that private link will only be able to reach to the function app. So on the other end, you can see that the public access is completely blocked. And function basically integrates within the virtual network using a VNet integration in order to get back onto the on-premises. And the second example I have here is premium functions supports non-HTTP triggers over private link. So imagine a scenario where you have a virtual network, you have a storage account configured with private link, and you want to create a function which listens to the blob events on storage account over private link. So a specific settings is now available in premium functions settings blade, which says that allow virtual network trigger to be able to reach to the function. And this is a settings that you might easily miss and run into issues. So make sure the virtual network trigger support is on in order for function to reach or respond to the events that a storage account over private link is firing. Okay. And here is a demo architecture, what I have set up. So what I have done is I created a DNS server, because anytime you work with private endpoint, you have to let the services know how to resolve those private endpoint IPs. So DNS server mapping allows me to configure a Azure DNS name to the private endpoint IP. So whenever either a client tool like VS Code or a request to function comes in, a DNS server can be able to translate that name, the Azure public name, to your private IP and able to respond. So on the virtual, so within this virtual network, I have 3 subnetworks. And first subnet is for the client tools or servers or whatever you want here, could be your deployment agent. The second subnet is specifically for private endpoints. And in that, I have configured 4 different private endpoints. So the first private endpoint is actually connecting to Key Vault. Again, a demo purpose that how you can privately connect to Key Vault to retrieve the secrets. The second private endpoint is for the storage account, which is a table storage account. The third one is a private endpoint to storage account, which will be the base for triggering of a blob events. And you can see that this storage account is also a VNet integrated into a default two subnets. So that way, the virtual network integration can actually call the backend services from within the virtual network. And a final VNet, final private endpoint is for function. So the function is exposed over a private endpoint, which means that the public access to this function URL is restricted. Could not come in and execute a function over public internet. The only way to execute this function is from being within this virtual network. So for example, I have a demo VS Code IDE set up here, the virtual machine be able to execute the function. Anything, any resource is connected by peering to this VNet can also be able to execute the function. But basically the public access is blocked. All right, so if you have any question, please feel free to ask. I will switch over to the demo now. Okay, so first of all, an experience about creating a premium function. So I just went into the Azure portal and I'm creating a new function app. So select the resource group, the name of the function app. You can choose from code or Docker container, same settings as you've been familiar with when creating a function app. Runtime stack, I can just select public .NET Core. The version is 3.1 and the region. So nothing new here so far, the premium function. So next, when go to the hosting, and here I can select the operating system, Linux versus Windows. So just to keep in mind, we'll just go with the Windows first. And here is your choice for a plan selection. So we have the consumption plan, we have the premium function plan, and the app service plan. So for premium function, we'll select the premium. And you can certainly create a new plan name. Okay, and the size. So as I mentioned in the deck earlier, that you have more control over resources, how much you want to allocate, as well as more choices. So from 3.5 gig memory and the total ACU, the credits for CPU, ranges in a 3 different tiers, the plan 1, 2, and 3. And based on your need, you can select the right size plan. So we'll go with this first EP1 plan. Okay, monitoring, and if you want, you can add tags and you can create. Okay, so while this is going on, we'll be switching back to the demo environment that I have here. So first is the DNS server. So making sure all of these DNS entries are present within your virtual network, so it can be able to translate the name, the DNS name, to the IP address. And so you can see here, I have a few entries for, so this is the function entry, which points to a private address, 10315. Same way I have an entry for the blob storage. So you can see that I have a private link enabled storage account pointing over 10314, as well as the SCM site for the function and the key vault. So essentially you can see that all of the resources that I have spin up in Azure, they all have a private IP, and that has been mapped here in the DNS server. Okay. Now we'll switch back to the Windows machine that I have. I will be developing from within this environment. So we'll go ahead and create a new function listening to the blob storage. But before we do that, let me see if I have one working. Okay, so essentially we'll give this a try first. The demo is that when a blob is uploaded into the storage account, it should fire up an Azure function. But the difference here is that the storage account is private endpoint enabled and VNet integrated. So we will be testing out the blob trigger within the virtual network integration environment. Okay. And almost everything out of box function, listening to the trigger. So if you see the definition here, the trigger is a blob storage trigger and the container to monitor is test. I think we will make a change here. The container is data items. Okay. And let's see if we can go back to functions and going to the log streaming. Okay. Okay. So we'll try to upload a file here. Okay, so we should be able to see the function firing off. Okay, and you can see that the function has been fired off the blob trigger, and it has find out that the new file c1.contact has been uploaded to the function. Any
Malik, one
questions?
question. Yeah, Malik, I have
Yes.
a question. Remember why we are not using a DNS private zone? Why we are using a custom DNS? Do you want to talk about it?
Yes. So primarily, and Navid, if you can certainly add, but the primary reason that private DNS zone is not yet supported for the functions or the app services, and that's to compensate that support, we are using the DNS server to map the DNS name to the IP.
Yeah, exactly. I mean, because we are just wanna. I mean, we wanted to clarify, and Malik, as Malik said, we do not have support for private DNS zone for VNet integration for app service or premium function. That's why you have to use a custom DNS. So once that support is available, the whole thing setting up your own DNS will not be required. So go ahead, Malik.
All right. Right. So again, just going back to the diagram, so you can still relate, right? So what we have shown here is that a storage account um, connected or over private endpoint, which is VNet integrated, is able to raise these events on over the network integration, and function app is able to respond. So it's basically an example of a non-HTTP based trigger eventing for functions within that network boundary. So the second demo I have is just a bonus, I think. So that one actually does a little bit more in the sense that it connects to the key vault over private endpoint and grabs the secret, and then goes to the storage account and upload a dummy file there. So let me just go back there. Okay, going back to functions. By the way, I'm trying the new portal experience, which is much more streamlined with app services and rest of the services in Azure. So we'll make sure that the app's running. Okay. And by the way, I also would like to show that the accessibility of a function is from within the virtual network. So I have this function, as you can see, it responded and it fetched the value from Key Vault. The function, if I go outside of the virtual network and try to get in, let's see what we get. So you can see here, you get the 403 message, which proves that the accessibility of a function is only over from the resources which are connected to that virtual network or in that virtual network. Okay. All right. Okay. So just checking the logs, see what happens. It didn't actually work out. Got the 500 error on the integration. So any questions so far? So by the way, I'm using VS Code for creating an HTTP trigger and accessing the key vault or managed service identity, as well as the code to use that managed service identity secret stored in key vault to connect to the storage account and then insert the data into the storage account. So we'll try to republish this function. Let's see. So to publish it from VS Code, select the subscription, go ahead and deploy. All right, let's get back. And try it one more time, see if it works. No, sorry about that. So seems like this is it. All right, guys. So any questions?
Yeah, you had can you go, are you able to go back to the architecture diagram for a second?
Sure.
Yeah, I just have a question. There was another subnet, that delegated tab service subnet. What is that? What is that do? I understand the other subnets, but that one in particular.
So whenever you do the VNet integration with any of the Azure services, it requires an empty subnet.
Oh,
Right?
that's what
So
it's for. Okay.
yeah, that's what it's for.
Okay. Okay. Okay.
Yep. Yep.
I see.
Yep.
Okay, so you access the key vault over the VNet integration through a private IP address, like an outbound request from the app function app, right?
So VNet integration is not required for Key Vault. It's just a private IP. So once you have the private endpoint pointing to Key Vault, many resources can reach to that IP, be able to connect. For the access control, I'm using managed service identity, which controls who and how can it be accessed.
Right, but the function app is able to reach the private IP of the key vault through the VNet integration, right? Capability?
That is correct.
Okay.
Yep.
And it's the
Yep.
same concept with the storage account, right? So the storage account, you've enabled it with a private endpoint, which gives it a private IP. And through the VNet integration capability, you're able to, I guess the function app is able to talk to that storage account through the private IP of the storage account.
Yep, that is correct. So the blob, the non-HTTP triggers of storage account is actually traversed through the VNet integration.
Awesome. Okay, thank you very much.
Absolutely. Yeah, this is a great capability for creating an intranet type of application, right? Where all of your resources are kind of provisioned in Azure, but only accessed via private IP. So great feature. And we are hoping it's going to be very useful for the enterprise organization where most of the applications are intranet type of applications.
Right.
Great. Thank you very much for the presentation.
Yeah, glad to be here again. Thanks, Navid, for an opportunity to share on Azure Power Lunch. And I think we will be about right time.
Thank you very much for joining. And as usual, I will upload the video to our YouTube channel, and the slide deck link would be there in the description. So please, download it if you want to watch it on demand, and join us for another session of Azure Power Lunch next week. Thank you very much, Malik. Really appreciate very good information.
Yep, glad to be on the session. Thanks, guys.
Yeah, thank you very much.
Great weekend, everyone.
Thank you. Bye-bye.